Hello everyone, in this video we're going to be talking about section 10.4, which is polar coordinates and polar graphs. So, polar coordinates. So far we've been representing graphs as a collection of points x, y on the rectangular coordinate system. In this section we will study a coordinate system called the polar coordinate system. Right? So it's just a different way to plot points on the coordinate plane. So to form the polar coordinate system in the plane, we fix a point O and call that the pole, right? Or even the origin, right? So this is going to be our point O. And then we construct from O an initial ray called the polar axis, right? So this is going to be my polar axis. Okay. And then each point P in the plane can be assigned polar coordinates r and theta as follows. R is a directed distance from O to P. Right? So my point P is going to be up here. I guess we'll do that in black as well. So this is going to be my point P that's in the polar coordinate system. And again, this is going to correspond to the point r theta. Right? And what is r and theta? Well, r is going to be this directed distance right here. This is r equals a directed distance from the origin O, or the pole O, to the point P. And then theta is counterclockwise, the angle from the polar axis. Right? And so again, every point in this plane can be written as r theta instead of xy. So in this type of system, unlike in the normal rectangular coordinate system, right, the rectangular coordinate system is more like a grid, right? We have a bunch of places and we plot points according to going up however many x values and to the right, to the right however many x values and up or down however many y values. Here in the polar coordinate system, it's more convenient to think about points with respect to a grid of concentric circles, right? So, because every point, remember, is listed as a radius and a theta, right? So the distance from, right, r is the directed distance from the origin or the pole to your point, and theta is the distance, the angle from the polar axis, right? So we should think of every point or all the different points as concentric circles instead of like a gridded, like in the rectangular coordinate system. So for example here, if I look at this point 2 pi over 3, again, what does that mean? The 2 means that it's a distance 2 away from the origin, so that's why it looks like it is the radius of a circle of radius 2, right? This would be the circle of radius 2, and then our guy is just 2 units away, so that's why it's on that circle of radius 2, and then it is theta equals pi over 3. So this angle right here, theta, is equal to pi over 3, and that's where we plot that point. Right? Again, it's just a point, just as x and y stuff is a point on the rectangular coordinate system. It's still just points on a coordinate system. We're just labeling them in a different way, describing them in a different way. So let's look at this next one here. This next one is 3. So again, this point lies on the circle of radius 3. So that's what that 3 means. And now it has an angle of negative pi over 6. Right? That negative means we go down pi over 6. Right? So that's why we call it negative pi over 6. Anytime we put a negative sign in front of the angle, that means go down or go clockwise instead of counterclockwise. Right? And notice that this point here, which is, if I write this same exact point in both coordinate systems, it's the exact same point, right? And I can describe it as the point 3 negative pi over 6 because I go down, or I could think of this as, hey, I'm going to go all the way around 11 pi over 6, right? That angle going all the way around from the positive, going counterclockwise from the positive x-axis is 11 pi over 6, right? So that's illuminating one difference between the coordinate system, the rectangular coordinate system, and the polar coordinate system, is the fact that rectangular coordinates have a unique representation, right? It has an x and y point, and that's just it. For polar coordinate systems, that's not the case, right? For instance, anytime you add 2 pi to a point, you get that point again, right? So for example, if I have negative pi over 6 and I add 2 pi, what do I end up getting? 11 pi over 6, right? So these 2 points, even though they have 2 different representations in the polar coordinate system, they're the exact same point, right? So that's one difference between the rectangular coordinate system and the polar coordinate system. Also, because r is a directed distance, the coordinates r theta and negative r theta plus pi represent the same point. So what am I trying to say here? I'm saying that if I had the point, so one way I could list this exact point. One way is by this guy. Right, so let's highlight it. One way is representing it like that. Another way is representing it like this. And then a third way we could represent it is say, hey, I want to go the angle, let's say the angle all the way to here. Right, this angle would be what, 5 pi over 6? And if I say, okay, I want the angle 5 pi over 6, but let's do the radius as negative 3. Remember, this radius is a directed distance, right? It's the distance from the origin to your point. So since I'm going backwards, negative, right? This was a positive theta, but then I go backwards, that puts it right there. So this is a third representation of the exact same point that we have talked about, right? So even that same point has 3 different, and actually every point has infinitely many different representations, just because of the fact of the periodicity of the unit circle. Okay, so let's go on to coordinate conversion. So to establish a relationship between polar and rectangular coordinates, let's let the polar axis coincide with the positive x-axis and the pole with the origin, right? So oftentimes what we're going to be doing now is we're not going to just make up this plot things in the rectangular coordinate system and then totally separate plot things in this random polar coordinate system. They actually coincide. And the way we're going to do that is we're going to say, okay, say this is the rectangular coordinate system, right? This is y and this is x. But let's also say that this is the polar coordinate system, right? So I think about this, I can think about it either as concentric circles like the polar coordinate system, or I can think about it as a grid like the rectangular coordinate system, right? So if this were the rectangular coordinate system, I'd have some point here, we'll call the point, write the point in black. So this is my point P, right? And this point in the rectangular coordinate system has x and y as its points, or its coordinates, sorry. So this is x, and this is y, right? And I'm actually going to erase this just because I don't want to get my picture too messy, right? Now, as a rectangular coordinate system, I also have that this is r, right? This distance right here is r, and this angle right here is theta, right? And again, this is where I've got here, I'm simultaneously thinking of this as the pole, which is what the center is in our polar coordinate system, or the origin, what I think about our center being in the x and y coordinate system, right? And so this x-axis is also our polar axis. Is that what we called it? Yeah, polar axis. So the x-axis is playing double duty as the polar axis, and the pole is playing double duty as the origin, right? And so this point represented as xy can also be represented as r theta, where again r is the distance from the origin or the pole to P, and theta is the angle it makes with the positive x-axis, right? And so this distance right here is x. This distance right here is y. What do you notice? That if I take x squared and then I get this is a right angle right here, right? So if I take x squared plus y squared, that's going to equal to r squared, right? Because that's through right triangle trigonometry and through the Pythagorean theorem, right? So I get r squared is equal to x squared plus y squared. So that's going to be a way for us to compare x and y coordinate system and x and y points to a polar the polar representation, right? So I can find r, and also through right triangle trig, we notice that we have 3 things. We have that tangent of theta is equal to y over x, right? So if I know y and x, I can find theta. I know that sine of theta is equal to y over r, and cosine of theta is equal to x over r, right? And I know that again from all this right triangle trig because we're plotting this point simultaneously on the polar and the rectangular coordinate system. So that's basically what this theorem is telling us. The theorem is telling us that if I have a polar point that's r theta and a rectangular point that is xy, if I want to go from polar to rectangular, I use x equals r cosine coming from right here. If I want to find my y, well, from right here I get y equals sine theta. If I want to go from rectangular to polar, if I can get theta through x and y like that, and I can get r through the Pythagorean theorem just like that. Right? So the first thing we're going to practice is going from rectangular coordinate systems to polar, and then from polar to rectangular. Actually, I think we're doing it the other way around, but you get the idea. Okay, so find the rectangular coordinates of the point r theta 2 pi. So first, let's go ahead and just practice plotting this on the x and y coordinate system, or actually, I'm sorry, on the polar coordinate system here. Here's x, here's y. 2 pi. Well, remember, what does that 2 mean? That means that I lie on the circle of radius 2 here, right? This is 2, this is 2. Pi means my distance from the, the angle from the positive x-axis. So in other words, pi would be all the way over there. So if I were going to draw this better, now that I think about all that information, this point, it's going to be a distance 2 away from the pole, and it's going to be an angle pi away. So it's going to be just this point right here. That's the point 2, 0, right? Because that's a distance r, and this is theta. But let's prove that, right? So how are we going to prove that? We know r and theta. So if I want to find x, x is equal to r cosine of theta. So again, what is r? R is 2, and then we do cosine of pi. What's cosine of pi? Cosine of pi is -1, so this is -2. Oops. And I should put -2 there, right? Because if I were going to do this in the rectangular coordinate system, I get -2, 0. So I guess I should plot this. Whoops. How did we plot this? We plotted this. This was 2 pi, right? That's how we plot it in the rectangular coordinate system. And our guess was what I just wrote out, that it should be -2, 0 in the rectangular coordinate system. So now let's prove that. So that's what we're doing here. Okay, so -2, and then y is equal to r sine theta. R is 2, sine at pi. Sine at pi is 0. So I get the point -2, 0, just like we had planned from practicing plotting it through the polar coordinate system. Okay, so now let's look at a next example. Find the rectangular coordinates of the point radical 3 pi over 6. This one won't be as easy for us to just pick out, but the idea, we can kind of get the idea here. So this would be, we want an angle of pi over 6, which we know is somewhere like right about here, right? And then it's distance radical 3, right? So that's kind of the idea here, is this is radical 3, and this is theta equals pi over 6, right? So we know it looks something like that. So now let's find its rectangular point or coordinates, right? So again, x equals r cosine of theta. R is going to be radical 3, cosine at pi over 6. Cosine at pi over 6 is going to give us cosine at pi over 6 is going to give us radical 3 over 2, right? So radical 3 times radical 3 over 2. Radical 3 times radical 3 is just 3, so I get 3 halves. Y is equal to r sine of theta. So radical 3 sine at pi over 6. Sine at pi over 6 is 1/2. So I get radical 3 over 2. So my point here is 3 halves radical 3 over 2, right? And plotting that, radical 3 over 2, the top of my head, I don't know that number, but I can plug it into the calculator real quick. 3 divided by 2 is about 0.866, right? So that means that this looks like this point, that's 3 halves, and radical 3 over 2. So that's this point right here. This is 3 halves. Radical 3 over 2. And it's also the point, if I thought about it in the rectangular coordinate system, just like we kind of thought of here, this is a distance of radical 3, and this is a theta equal to pi over 6. Right, so this is also the point radical 3 pi over 6. Right, so two different representations of it. All right, so now let's look at one more here, actually two more. Let's go the other way around. Let's find the polar coordinates given the points in xy. So this is the more complicated way. It's much easier to go from rectangular to, from polar to rectangular. It's a little bit harder to go from rectangular to polar. And the point, or the reason why, is because remember, in the polar coordinate system, there's multiple ways to represent one point, right? I can put different thetas on it, different angles, and different directions of my radius to give me different representations of it. So in this, if we look at this point, xy, it is -1, 1. So on the rectangular coordinate system, this looks like this point right here. That would be the point -1, 1. So notice that is in quadrant 2. So when we go to pick our theta, we should pick our theta in quadrant 2, or if we don't, we have to be consistent with our r, right? Okay, so how do we find theta? We find theta through the tangent theta equals y over x, right? So tangent of theta is equal to y over x, which is 1 over -1 or -1. So that means that theta, when is theta equal to -1? Well, it is equal to -1 at 3 pi over 4, right? Because the pi over 4s are the ones that are radical 2 over 2, right? So 3 pi over 4, and that is consistent with this one, because also we know that 7 pi over 4 would give us tangent, well, actually not negative, it would be the other one. So if I had 7 pi over 8, 9 pi over 4, 9 pi over 4 would also give us tangent equals to -1, but that's not the one we want, because 9 pi over 4 is going to give us a fourth quadrant, right? So this is the theta that we want. Now we got to find our radius. So we do r squared is equal to x squared plus y squared. Well, x squared is going to be -1 squared plus y squared is +1 squared. So out here I get 2. So that means that r is equal to the square root of 2. So one representation is going to be 3, well actually our radius comes first, so radical 2 and then 3 pi over 4. Right, that's one possible representation. Just for funsies, let's talk about another representation, right? Another representation would be going down this theta to get to this point right here and then giving us a negative radius, right? So another one would be, another representation could be okay, let's do, the angle would be negative pi over 4, because that would get us right down to this point, and then I need to give it a negative radius to get it up to that point. So then I put negative radical 2. All right, so this is a different representation of the exact same point, right? Okay, And now this one's actually a little bit easier. We could probably do this one without actually doing any work, and then we'll prove why we can do it, right? So let's look at the xy point that is 0, 2. So that's just 1, 2. It's just this point right here. So this is the point 0, 2. And now if I was going to do this in polar coordinates, well, I'm exactly, because I'm exactly vertical from the pole, I know that I'm 2 units away, so my radius is 2, and then what's my angle? My angle is just going to be pi over 2, right? So that would be the point in rectangular coordinates. But let's prove why that is, right? So tangent of theta is equal to y over x. Well, actually, if I look y over x, I'm going to be in trouble, right? So I noticed that because I'm on the y axis, I know that my angle is going to be pi over 2. Right? Because if I try to do y over x, I'd end up with 2 over 0, which would get me in trouble, right? But I can just use common sense here to get that one. Now, r squared is equal to x squared plus y squared. X squared is 0, so 0 squared plus 2 squared is going to give me 4, so that means r is equal to 2, right? So just as we expected, r equals 2, theta equals pi over 2, and that would work. An alternative one, right, so this is the point 2 pi over 2. Again, an alternative would be, say, negative pi over 2, negative 2 and negative pi over 2. Right? Or even negative 2 and 3 pi over 2 would be another one. Right? So there's infinitely many ways that I could represent this point on the rectangular or on the polar coordinate system. All right, I'll go ahead and end this video here.